previous session, what we have discussed in the previous session. So in the previous session, we have discussed about the introduction to solar energy. So you might be aware that what is meant by solar energy. So the energy which we are getting from the sun is called as the solar energy. This we have discussed. We have discussed the different types of energies available, the renewable energy and non-renewable energy. The renewable energy is the energy which is eco-friendly and is not exhaustible, but whereas the non-renewable energy is exhaustible. These discussions we have made in the previous class. So before going to the today's class, we will have a small discussion on our topic. So we can see here a picture is available. What we can infer from this picture? So by seeing the picture, we can see here this is a sun and these are clouds. So what we understand from this picture is that a sun is a source of energy. It emits a lot of heat energy. So now this is the highlight behind this picture. So sun is a source of the light energy and heat energy. Now going to the second picture. So what we can see here, we can see here a small ground and then a person is standing here, he is doing some activity. So what is this activity? So this is the activity, he is doing a yoga or he is doing a Surya Namaskar. So what is Surya Namaskar is? So he is focusing the sun and he is making the light energy to fall on his body. So this habit is good to our health. If we do in our day-to-day life, it will be really benefit to us. So why we have related this to our topic, this picture? So he is dependent on this sun. So the energy obtained from the sun is taken by the person who is standing here. So that is Surya Namaskar. So from these two pictures, can you judge what the topic we are going to discuss today? Any ideas? So today our topic is the solar radiation on Earth's surface. This is our topic. So now let us go over to the next slide. Sun, a source of energy. So in the solar system, sun is an available source of biggest energy. So here in the sun is very a hot sphere which is composed of a gaseous matter, and if in this picture we can see here the solar radiation is emitted towards the earth. So in this picture you can see here the size of the picture of this is the sun and this is the earth. So here the difference in size makes us the view from the magnetic radiations. So here the diameter of the sun is about 1.3 to 10 power 9 meters and the temperature is very high. So we can't imagine the temperature there. See the temperature here. So it is given in the red gaseous matter form. So here the sun emits the energy in the form of electromagnetic waves. So the radiation from the sun comes to the earth in the form of electromagnetic waves. Now let us see. Let us see what happens to the solar radiation. Or we are getting all the solar radiation on the Earth's surface. Or is any factors which is to be considered. So as the Earth is revolving around the sun and rotating by itself, the solar radiation falling on the Earth is not constant throughout the day or the month or the particular towers. So it will be very easy. So one example I have given here. We can see here this picture. So from this picture, what we can infer? If you see here, it is clear that it is what type of land? So it is a desert. So in this picture, it is a dry desert. So what we know from this picture is that in this place, the temperature is very hot. In India, Rajasthan, Thar desert is available where the temperature is very, very high. So that is the geographical location. So in this area we can get most of the solar radiation on the particular place. So the tapped solar energy can be used for many purposes if we install the solar radiation tapping devices in this geographical location. If we take a different location, if we take Jammu Kashmir, if we go there, we can see only the mountains full of snowfall and ices. So there the temperature is different. Though we are getting the solar radiation, the amount of solar radiation is different. Coming to the next, time of the day. So the solar radiation depends on the time of the day. Because in our day-to-day life, we can see that during the morning hours, we can wake up, we can see the sun rising and it sets at the evening. But in the real time, in the noon time, we can see the people wandering outside is lesser. What is the reason? The reason behind this is the radiation of the surface on the earth surface is maximum during the noon time. So that is why all the birds or animals, they do their all the works during the ourselves we do the works, and the animals and birds also go for their foods during the morning hours and stay in their nests during the afternoon hours. So it's because of this solar radiation. And third one is season. So here in the season, during the winter season and summer seasons, the solar radiation differs. In the summer season, more amount of solar radiation is on the earth surface, whereas in the winters, the amount of radiation is lesser. And coming to the local landscape and local weather. So if you take our place, so we are in Coimbatore now, we can feel that, we can see outside, we can feel that it is a sunny day. But nearby, if we go to a nearby hill station, Ooty, the scenario is different. So the temperature, the sunlight is falling on there, but the radiation, the amount of solar radiation falling is differing from place to place. That is the local landscape and local weather. If you go for Ooty, we can feel the climate as chill. So these are the main factors which disturbs the solar radiation on the earth surface. Next, let us see how the solar radiation is emitted. So in this picture, what you can see here there is a neutron, helium, deuterium and tritium. So here what happens? So here the radiant energy, see here. So the radiant energy is emitted from the sun. So how this happens? So this is happening because of this nuclear fusion reaction. Can you know what is called nuclear fusion and nuclear fission? Where we are studying nuclear fission? So nuclear fission is the process which is taking place in the nuclear power plants. If we take the uranium, so in the nuclear power plant, the fission process takes place, splitting of atoms and nucleus takes place. So when the splitting takes place, large amount of heat is liberated. Whereas here, the fusion, the joining of the process takes place and the heat is liberated. So the energy liberated here is the electromagnetic energy. And coming for this, so what will be the solar radiation and what will be the temperature? So the temperature is nearly around 5800 Kelvin is the temperature of the sun. So think what is the real temperature there. How imagine how it is. If you take in the real time, the temperature available here now is the room temperature may be around some 28 degree to 30 degrees Celsius. So compare with this. Compare to 30. What happens here is it is around 5800 Kelvin. Okay. Now let us see how the solar energy is on the earth. So here, this is of the solar spectrum. We can see here, this is the radio waves and the microwaves, infrared radiation, visible light, ultraviolet, solar radiation spectrum, X-rays and gamma rays. So what is this? So the solar radiation falling on the earth is categorized in these forms. So here it forms a solar spectrum and it has a broad range, and all this based on this electromagnetic radiation, and these are the synchronized oscillation of electric and mechanical fields, and this propagates in the speed of the light. So this is how the solar energy is reaching on the earth. Now let us see. So we have discussed in the previous slides how the solar radiation is falling on the earth, and now we are going to discuss how much amount of solar radiation is liberated from the sun and how much we receive on the earth, and what happens on the way when it reaches the earth. So from this we can see some few pictures. See here, this is the sun, and assume this is the earth, and here there is some clouds. So what happens here? So the sun's solar radiation which is emitted, only around 46% of the solar radiation is falling on our earth. So what happens to the remaining 54%? What happens? So only we are getting 46%. So here around 19% of the energy is absorbed by the vapor and by the ozone layer and the dust particles available in the atmosphere, and whereas 8% is dispersed in the atmosphere due to various reasons. It is dispersed, and 4% of the solar energy is absorbed by the clouds, and here some 17% is reflected back by the clouds. So when you get this total here, totally around 54% of the solar energy is absorbed by these clouds and the dust particles and by the ozone layers. So here you can see this 6%. So from all these barriers, the solar radiation coming to the earth is again reflected back on the earth's surface due to some particles or elements or due to some reasons. So from this, what we are inferring is that only around 46% of solar energy is absorbed by the earth, and remaining 54% is returned back due to these various reasons. So now let us see. So we are receiving the solar energy, and what are the types of radiation which is falling on the earth? So if we see here, the sun emits in the radiation of 0.15 to 120 micrometers. The energy band gap is 0.15 to 120 micrometers, and here we almost see the solar energy, and the wavelength is between 0.15 to 4 mm. This is the wavelength, and coming here, so the radiation in this range is consists of UV ultraviolet radiation also, and it has some visible radiation and also infrared radiations. So now let us go for a small table and we will have a small comparison of the range of the wavelength and how much energy is carried. So before going there, we will discuss what are the radiations available. So the first one is the ultraviolet radiation and visible radiation. VR is nothing but visible radiation. IR is nothing but infrared radiation and others. All the other than these three categories considered as others. So here in the wavelength, ultraviolet range wavelength is of 0.15 to 0.38 that we have mentioned here. So what is the energy carried is around 7.6%. And see the visible light. So the visible radiation is around 0.38 into 0.72. The range is in between 0.38 and 0.72. So the total energy carried is 48.4%. And here infrared, the range is 0.72 to 4 and the percentage of the energy carried is 43. And others is greater than 4. Wavelength is greater than 4 and the available percentage is only 1. So what we infer this? So for all the purpose, if we take this classroom, so this is a daytime. So we are feeling comfortable without any lights. Why? Because the normal visible lights, visible radiation falling on the earth makes us comfortable during the daytime. So without the lights, we are sitting inside, we feel comfortable. Whereas in the night time, so this visible radiation is not available. Okay. So next we are discussing about the solar irradiance. So what is meant by solar irradiance? If we take a sun, so this is in the morning hours and this is in the evening hours. If we draw a small variation like this, so what happens is we can stand here and we can see here. So this is the sunrise. This is in the morning and sun sets at the evening. So here this is the range of the sunlight. We are considering this the flow of the sun's ray. See here. So here we are having a small graph. So what is the graph is? In the x-axis we are taking the time of the day and in y-axis we are taking the solar irradiance. So the time of the day and solar irradiance is given by watt per meter square. So now if we predict and based on this solar radiation, so here at the morning hours, if we take the time as 6 a.m. and we can go it for 6 p.m. and this time may be varying in hours. So here what happens is for each and every hour we can measure the solar irradiation. So what happening is the solar irradiation is going on increasing. See, it goes on increasing, again it is decreasing. See here, from the initial of the graph, it goes on increasing and it increases the maximum. If you take a benchmark like this from here, see here, see the difference. So the radiation is increased and it is decreased. If we compare this radiation, if we compare the solar radiation with the time, so it may be here 6 a.m., here it is 6 p.m. So here there will be around 12 noon. Because if we consider it is around 12 noon. So what we get from this? This we have made here. So what from this graph, what we come to know is that the solar irradiation is maximum at the noon time. So in the morning hours, the solar irradiation is lesser, and in the evening time it is also lesser, whereas in the noon time the solar irradiance is maximum that we are inferring here at this particular point. So we can get the area. See here, we can get the area. So this area, this orange color area gives the total solar irradiation falling on that particular time period. This we can make as we can calculate for a particular hour or for a particular period of minutes or for a day, or we can go for all the days and we can calculate for a month, and we can make the calculation for all the months and we can get the data throughout the year. So this is. So now coming to the definition. So solar irradiation is nothing but the amount of solar power we are getting from per unit area. So this is solar irradiation. So this solar irradiations takes place with respect to the time. So this is about solar irradiation. So from this we infer that during the noon time we are getting maximum amount of solar energy. And here see here. So from this see here. This is a small unit area. What is unit area? So we can make a small experiment. We can do a small case study here. So how to calculate the solar irradiance? So we can take a small amount of glass material and we can place it in the sun. And then what happens is we can calculate what is the solar radiation falling on the particular surface. So here this is made possible for the calculating the amount of solar radiations. And see here. So now coming to the radiation. So we have discussed so what is meant by solar radiation, how the sun is emitting, what are the types of solar radiation, and then how it is reaching the earth, how much percentage of energy is dispersed. And now from this we are seeing what is the types of solar radiation. So this we can go for a small story. In our small ages, when we go for small festivals and some functions in the festivals, there will be a small glass material, a small handle and a small glass material, so which will be sold for 5 rupees or 10 rupees in the festivals. So they will tell in Tamil it is as a Buddha Kannadi, they will tell. So what we do is, when we take our hand and keep that sunlight like this, when we keep that glass material towards the sunlight, what happens is the solar radiation falling on the particular point will focusing on the hand. So within a few minutes, what happens is, so this is get heated and we can feel the heat and suddenly we can take our hand. So instead, if we keep a paper, within a few seconds or few minutes, what happens is that particular area will be burning. So this is solar radiation. So here there are 3 types of radiations. One is beam radiation, and next one is diffused radiation, and third one is global radiation. So these are the 3 types of radiation available. So one is beam radiation. What is beam radiation? So there is sun. Okay. So this is a small sun. And this is the earth surface. So here what happens is, when the radiation is directly falling on the earth surface. So when the radiation is directly falling on the earth surface, then this is called as beam radiation. This is beam radiation. So what is meant by diffused radiation? So there are some clouds. Okay. So the radiation falling on the clouds is made to reflect. So it is falling on the cloud and it is reflected. So this is called as diffused radiation, DR. So now we can understand is the diffused radiation, the beam radiation is the beam radiation is directly falling on the earth surface, whereas the diffused radiation is disturbed and it is falling on the earth surface. So now we have discussed about the diffused radiation. Now coming to the next. So what is meant by global radiation? So the combination of beam radiation plus diffused radiation gives the global radiation. So these are the three types of radiations available in the earth surface. So beam radiation, diffused radiation and global radiation. So here we have made here with the help of a small graph. We have taken the standard time in the x-axis and the irradiation on the y-axis. See here we have started with 5 AM and we have ended with 7 PM. So the graph is made between each 1 hour from 5 to 6, 6 to 7, 7 to 8. For each 1 hour we have taken the solar irradiation and we have made the graph. See here. Here you can see 3 different graphs available. One is in the blue color, one is in the red color, and another one is in the yellow color. So what we come to know, see here. In this, here it is 1000 watts per meter square. This is the solar radiation. See. The diffuse direct beam radiation gives the maximum amount of solar radiation. See, it reaches around 1067. See here from this graph. So this direct beam radiation gives the maximum amount of solar energy, whereas the global radiation is below 1000 watt per meter square. So this gives the second, and the diffuse radiation, see here, it is very lesser. So when we make the average between the direct and the diffuse radiation, we are getting this global radiation. So from this, what we come to know is the direct radiation falling on the earth surface is maximum and the scattered radiation is very lesser, and we take average and we can obtain the radiations. So this is about the radiation is the time. And this is about the direct diffuse orbital radiation. See here what happens is there is many obstructions. See here absorption radiation, diffuse, direct radiation, earth surface. What we have discussed here is made in a small picture. Now there is a small puzzle for you. So you can, from this diagram, you can tell me. So other than this, what are all the radiations? What are all the other factors which is affecting the radiation? Okay. And see here. So we are going to a new topic as the air mass. See here. This is the earth surface and this is the earth, and we are getting at the sun rays. See this in the first picture we can see the sun rays is falling straightly. So you see the line here. So the line is falling straightly. So here when the solar radiation is a straight line, see here. So the air mass is around 1. So what is air mass? It is the amount of atmospheric radiation it is put through the earth surface. So see here. So the amount of atmospheric radiation that must pass through to reach the earth surface. See here. So what happens is this straight line is made vertical like this. It is inclined. Okay. So here it is around 42 degree inclination. Around 42 to 45 degree there is inclination. So this is called as the zenith angle, and here because of this the air mass ratio is around 1.5, whereas here it is 1. Okay. And we'll go for assessment on this Kahoot. We have small questions. Okay. That we will see later. And I have made a small references from the NGRI, theenergyworld.com, and you can go for this wiley.com and inference.physics.com. So before concluding, what shall we do is we have a small recap from the previous sessions. What we have discussed in the from the beginning, we will have a small recap. So first we have discussed about the sun and what is the source of energy. Sun is the source of energy, we have discussed. Then we have discussed what are the factors are influencing. Mainly these are the factors are influencing solar radiation of the earth surface. Then we have discussed about the solar radiation, and we have seen what is about the electromagnetic spectrum on solar energy on the earth. And here we have seen how much amount of solar energy is observed and how much is dispersed. And we have seen what is the range of solar radiation available. We have discussed about these available ranges. And we have discussed about what is the solar irradiance, and we have made a comparison with the time and the solar irradiations. And we have made a small possible experimental part to make the solar radiation. And we have discussed the graphical of the solar radiation falling, and the types of solar radiation, direct, diffuse and albedo radiations. And we have discussed about the air mass, how the air mass is varying and how the zenith angle is obtained. And this is a small assessment and reference. So dear friends, we conclude this session about this